Good morning, ladies and gentlemen of Precalculus. Welcome in room 15, where it never ends. Now, sometimes it'll slow down, like during a long weekend. I hope it was a good, productive weekend for everybody, at least enjoyable weekend. Was it an enjoyable weekend?
Yeah, it was pretty cool.
Okay, good.
Some days just kind of melt together.
Yeah. But right here, I brought this up at the beginning of class because this came up during first period on Thursday about the learning pyramid, which explains, I think, quite a lot of what we do, why we do things the way we do in this classroom. Does lecture happen in this classroom? Yeah, it does. Does it happen very much? Yeah, but I hope the lectures aren't that long, right? And so basically, since you're not going to retain a lot from them, so if you spend a little time as possible on these things, and we try to arrange things so that as much time as possible is spent. So when I have you work on a problem, get ready to present a problem and all that, what we're trying to do is encourage ourselves to get down in these types of things. Lower on the pyramid. Now, what's a drawback of that? What's a price that has to be paid for doing it this way? What's the price we pay for doing it this way? It takes longer. It takes longer, and over the time of the class, over a year-long class, we're not going to be able to zip through as much material as quickly because of that. But I'd rather us take some time and just try to learn what we learned pretty well. And so that's the reason we do it. So I know I've talked about this before a long time ago, but that's why we do it. Okay, but now we get to where we left off on last Thursday, and I had everybody stop right here at problem 35. And problem 35 on in this section. By the way, this section 4.1 in our book is really quite important as far as what's being tested, because a lot of what's being tested is right here in section 4.1. Degrees to radians, radians to degrees, use of the arc length formula. And one reason I wanted to stop right here, there's going to be a problem that is challenging for some students. This one right here. Oh, but I forgot to mention one thing. One thing I did over the break is I did a little research about the prom. So prom is going to be located over here at this yacht club. And what happened is I noticed, you see what's written down here in the center? The coordinates in degrees, minutes, seconds, right? So the location of the yacht club is 32 degrees, 52 minutes, and 42.312 seconds north, 96 degrees, 28 minutes, 58.08 seconds west. So that's what that is. Okay. You want to cut a sector out. What is a sector? What is a sector, or what does it look like?
Like an area, like a little piece?
Yeah, it's a piece, okay? It's a piece. And so if we have a circle like this, and so if we take a 10-degree sector, so yeah, so it's a thin pizza slice. So if we cut a pizza into 10-degree slices, how many slices would we be cutting? 36, right? 36 slice. So this would be like a 36 slice pizza. It'd have to be a really big pizza to do that. And we'd still have skinny pieces. But anyway, so this would be a pizza with a radius, with a diameter of 22 inches, wouldn't it? So your perimeter is going to be 11 by 11 by that. So how do we find out what those distances are?
Can you see the Tom's place?
No, after the thing.
So the arc length formula. So perimeter is going to be equal to 11 plus 11 plus, how do we find the arc length? S is equal to R theta, but we're in degrees, so what do we do to adjust for degrees?
Gotta multiply it by however
However, 180, right? Plus 11 times 10 times pi over 180. So we go ahead and work all that out. Oh, it's right here from third period. See that? 23.920 inches.
I'm gonna laugh.
Okay, does that make sense? So you got our S here, and it's going to be 11.
Bless you. Who
Bless
is
you.
that? Who's these?
Jack.
Okay, what I want you to do is I want you to do number 36. I'll call on somebody to work out number 36 in a few minutes.
Didn't see that part.
White snow.
Diane, you could
Look, big, that's definitely.
Okay, yeah, I have
I don't want to go Shane might know. She plays soccer, dude.
What? This does not have to do with anything. I'm not.
You actually get a toy? Yours is not your dad's. Is that your dad? That is kind of cool.
What is it? What's it?
It's none of your business, Cheyenne.
What is it?
Yeah.
Okay, for number 36, we have Haley.
His card number.
You can do them, so you can do your own, right? You know that, right? That will work, I can get like all your own.
Yeah, that was my mom has it.
Brittany has her turn like whole thing on it.
Well, mine does good. It doesn't do the Apple Pay, it doesn't do the tap pay, it
Rather
doesn't
than
do
breaking that.
then what is those? Then it would even. Okay, do that.
That was right.
What type of,
So he's using the ArcLink formula, plugging everything in, right?
First National? We had like 3 banks.
I want to switch to Chase.
Bank?
The closest Chase is in
Or
maybe me and like 3 years.
we do the 180 because of why, because it's in,
100 degrees.
it's in degrees.
Yeah, but it was already your radius.
Okay, now he's kind of, he's sort of desert wasteland on the, right?
Yeah.
Divide the cancel out. He has the formula, that's supposed to be pi over 180. See, I did the same way you did, see. Right? Cross multiplies 180. And he has 4.01 centimeters.
Now you can ask them.
Okay.
Now, what I want to do is I want to talk like I did, I mentioned a little bit about to the other class about, I want you to try to grow and develop some intuition on what happens here on these things. You got a 100-degree arc of a circle, has a length of 7 centimeters. Do you remember that I told you how many degrees were in a radian?
53.
Wait.
So Ben was pretty close.
Think about the circle.
About 57.3, okay, which is 180 divided by pi. So 180 divided by pi is about 57.3. All right, so that many degrees.
Your basement.
Okay,
Your basement, just basement.
so what that's telling you
Sharon, you have a basement?
is, what's that telling you is that we have this angle right here, which is a little greater than 90, maybe about like that. Does that look a little greater than 90?
Yes.
And so we have this arc length right here, and we know this is 7 centimeters. So if this is 7 centimeters and this is drawn to scale, what is this radius here going to be in relation to that?
Less than.
Yeah, less than 7, probably bigger than half, right? Okay. So anyway, that's some intuition. And if you had this one here that was pi radian, that was just 1 radian, or 57.3 degrees, and we knew this piece here was 7, well, then we know the radius would be exactly 7. So that's what I want you to think before you start calculating what an answer should be, and that's going to be your correct answer right there. Okay. So that should be about.
Is that a new shirt?
Yeah, that's a new shirt.
I like.
Yeah, thanks. It's my wife made it.
Purple and red.
It's a what?
I like that, I'm so used to doing that. I do that.
Oh, okay, yeah.
That's my dad.
Yeah, that's right. That's right. It's easy to do that.
I think I remember being in like 6th grade and I had to explain something to Connor and I was like, Connor, you're gonna make that one.
Yeah, Cheyenne. Oh, Sal, excuse me.
Yes.
Yes.
Being like,
Sal said, this shirt here,
Something like that.
I like it?
math, it's all fun and games until someone divides by zero.
The exact year, I said to
We go over rational functions, equations.
Yeah.
We've done that in this class first
I've
semester.
never, I've
Hey,
had a
can we
lot
see the
of
venue, Mr. G?
What'd you say?
Can we see the prom place?
the venue. What it looks
No, I don't want to show that right now. Maybe toward the end of class, we might have some extra time.
know you.
like? Okay.
Okay. Let's get this next thing going here.
It's kind of cool.
You need to look like that.
It might actually be.
It says I'm not on the app. It's not hard. Push the buttons forward.
And you do?
You go back, you go left, you go right.
Hey, for real? Swear. Dude. Right now.
Yes.
Get that happening. Still will make.
What is it?
Practice.
I'm not.
Okay, I don't work all day.
I thought you worked at groceries. You're welcome.
Why don't I say me do lovely paragraph? She sent some picture of their moms, you know, like you follow on Facebook with all of them.
My mom does that to me all the time.
Yeah, it's so
And she's
weird.
like, you may hate your mom today, but
Yeah.
whenever she dies, you'll love her and miss her, or something like that.
I said it to me all the time, I'm like, miss it every day.
It reminds me of my heart too.
Okay.
I'm just gonna stop talking.
Okay. So now we're to this next section, which is the application of this.
You know what, do you need a heart?
Oh, maybe a big fan heart.
Actually, I think for that.
You did.
Yeah, I know, I thought about that.
These are the biggest heartbreakers in the school. I think we'll be the biggest heart.
Okay, we are,
You and that one girl, wasn't it? Is it Lily Gray? What's that?
okay, we're to this section right here, where we have 44. And so basically we're looking at applications of arc length formula, essentially. So you have a table here where you got 3 types of cars.
Each builder.
Find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute.
That's what you did. Work out.
So
I don't.
so you have parts A, B, and C. Let's go ahead and look at this. The table shows the size specifications for the tires, come with standard equipment. So how are you going to find the speed of each vehicle in miles per hour when the wheels are turning at 8 revolutions per minute? What would you do for that?
Well, what is the tire type? What are those ones? That matters.
Yeah, this right here, this is an example of data that isn't going to be helpful to us.
Oh, it's not.
Is it actually?
You know how tires are?
We don't care about these types here.
Yeah.
We care about, what do we care about?
The diameter.
We care about the diameter, and why do we care about the diameter?
The stage of the wheel, the left revolutions start with that.
This one.
Yeah, small.
Yeah, so you guys got the idea. I hear Ben and Steve-O and Jack explaining what it is, yeah. Bigger tire with the same number of revolutions, that's faster, right? But what formula can we use for this?
Speed.
Yeah, distance equals rate times time. Yeah, that's a good thing. But what formula that we've been using recently in this class would be helpful?
The arc.
The arc length formula, you think?
Maybe. Yeah, like they have speed.
Good job, Steve.
Yeah. So what's the arc length formula?
S equals R theta.
No, we're trying to figure out what.
R theta, right? So we would, with this, what are we going to do with this formula?
Well, we have the radius.
Yeah, the radius. So we'll find a revolution is going to be, so one revolution is going to be equal to radius. What's our radius? We're going to do the Ford Taurus first. So I'm going to do the Ford Taurus. What's our radius going to be here? Yeah, 13.08. And what's theta going to be?
My fingernails.
360.
Yeah, 360 is 360 degrees, but remember 360 times pi over 180, which is going to be 2 pi.
Oh yeah.
2 pi radius. So this is going to be this. That's going to be one revolution. So it's going to be this one right here, 82.184 inches.
Take that.
So how do we find how far we go at 800 revolutions per minute?
Yeah.
Yeah, times 800. So we have our speed
Yeah.
is going to be equal to our one revolution, and it's going to be 800 revolutions per minute, right? So that's going to be inches per minute. How do we convert this into miles per hour?
You multiply it by
Dang, you had it.
60. Oh, over.
Yeah, so 60 minutes per hour, right? And so using dimensional analysis, we can just go and start canceling stuff out, right? So that cancels that. What do we need to change inches to? Miles. How do we change that to miles?
I haven't seen you get all pain lately.
So how many inches do we have in a foot? 12 inches per mile. And then how many feet do we have in a mile? That's foot, excuse me, I got it wrong here. Per foot, and 5280 per mile. What cancels out now?
Feet and inches.
Feet cancel out inches. So we're going to have left mile per hour. So what is that going to be in miles per hour? Well, it's gonna be this right here. 50, it's gonna be 82, 184 times 800 times 60 divided by 12 divided by 5280.
And to think I was gonna leave you.
So about 62.26
Not anymore.
miles per hour. We went to 3 decimal places during third period, okay? So what I want you to do is go ahead and do the same thing with your Dodge Charger and your Mercury and Mariner. And I'll call on somebody to work those out here in just a few minutes.
You type more left than this one,
Yeah, this is the
no. Yeah, I'm okay.
Who's me?
You think more than everything I do. Can I do more than everything? Like you do.
That's like you bullying baby and something you make you like die. And then take
Doc Martens.
Doc Martens Brooks.
You don't know what that means?
Oh, you're stupid.
I don't think I ever seen one stupid person here.
I love that last word.
Oh, never mind, now I get it.
You don't
Yeah.
remember that?
Oh, stop. Yeah, now I get it.
Okay.
Let's see if I'm right.
Okay, then I know who it is. I'm trying to remember that.
Fuck you.
What's your problem?
I don't know what I'm doing.
Honestly, how do you do that?
Peyton drank it and smashed it. Babe, babe, you okay?
Go Steven, babe.
You have Joe baby?
He did take a selfie.
What?
Yeah, I
Is
did.
it?
What did you have to take that selfie
Take
for?
her, bro.
No, no,
Why?
no.
You got Steven?
Honestly, who am I going to prom with?
Steven? Or yourself?
That's not what I'm saying.
Myself. Me and myself.
With Randy. I'm not gay. I like boys.
She likes that link, dude.
Okay,
Oh, what's his name? Doesn't he have a Jeep? Doesn't he have a Jeep?
Quit. I stopped talking with him.
Oh, yeah, you like that little short guy, that's right. What's his name?
okay, this one here we have Rindy.
I mean, that's the only way I know him, the short guy.
We're talking about Wilson.
What's his name? What's that name?
You don't like Wilson. He's an albino.
Isn't the albinos?
He is an albino.
It is.
Wait, who do we have?
So you're racist?
Rindy. Rindy, if you can just put down like for the Dodge Charger and the Mercury Mariner, what they are, it's the same type of calculation.
Okay. Hey, Ben. When did you get up? Wait, have you even done
It
it?
looks like her, bro.
Where's your work?
This year.
It's not working. structure is there.
It's like James Everest, we like jerky.
Really?
Yeah, that's possible. Yeah.
I used to have bushy eyebrows.
Used to.
Probably.
I don't.
I used to like not have eyebrows.
You know what? I'm gonna walk out.
Okay.
Yeah, you business.
I wish I
I know.
could walk out. Yeah, you will.
You're not leaving me in your
I'm
shiny.
not. I'm not. There's a park today. I never see that. Wait, is it mine? Oh no, it's not. It was black. I got really scared. You know, you're really rude.
Thank you.
Why is that happening? Are you okay?
Yeah.
No, my ears.
Pretty sure.
Connor, Connor, I can embarrass you right now.
Shut up, not funny.
What?
I love midgets. I don't know midgets. There's a midget coming in before, he's like 65.
How do I find out how many revolutions it makes? Because what you did was miles per hour.
It's not a nail shop.
It says how many more revolutions per
That's
minute.
impressive.
Or do I just put it where I keyed it in and just go?
I'm really upset.
Why are you up so shiny?
It's my favorite.
Hey, are you good?
Well, that has nothing to do
What
with
it is.
Actually, it has a lot to do with it.
Do you, but when you, so a lot of you've worked it out by now, are you gonna get a faster speed or a slower speed?
Ow.
Steve-O faster, why are you gonna get faster? Bigger tires, right? So bigger tires at the same rate of revolution is gonna give you more, right? So the calculation, Randy, is the same thing, isn't it? You just plugged in different numbers, didn't you?
Probably.
All right, thanks. Thank you. Thank you. So the only thing she did here was she had to plug it in different radiuses here, getting a different number here, go in here, is that right?
Yeah.
Everything else is good. Okay, part B. How, compared to the Mercury Mariner, how many more revolutions must the tire of the Ford Taurus make in order to travel a mile? How are you going to work that one out?
Well, you first gotta get, because right now it's miles per hour, so you just gotta get it hours per mile.
Hours per mile? Well, how about revolutions per mile,
Yeah.
right? Yeah, let's try revolutions per mile.
No. Give me more space.
So here, yeah, so here we have revolutions. Here's a revolution. How many do we get revolutions per mile? Well, so we have to know how many inches are in a mile, don't we?
That was
I'm not hearing.
63,360.
So revolutions per mile, let's figure that out. So we get 80,
I don't know.
we want to divide that into a mile, right? So we want to take 1 mile has how many inches? So we want to have, we want to take 50,
5280 times 12.
we have 5280 up here above. So 5280 feet per mile. And also we have to go ahead and get to inches, right? So 12 inches per foot, right? So we're going to get 5280 times 12 and divide by that. But we want to find for the Mercury Mariner, and that's the Ford Taurus, right? So 5280.
I saw his shoes earlier, and I was like, there's something wrong with that. I don't know what it is.
Like, did you just like have a crisis or like you don't have any clue?
And we're going to divide that by this 82.184, right?
I have pop tarts left. Okay.
So that many revolutions per mile? Is that right? So 770.95 revolutions per mile. And then for the Mercury Mariner, well, that's going to be a similar calculation, except we're going to have, that's going to be what, 14.475, is that right? 14.475 times 2 pi.
Peyton's gonna live alone for the rest of his life.
It's gonna have one too.
So we're going to take, so we can just divide that out by,
Bullying him, you know, really.
Yeah, we can do it locally. If it's raining or if it's snowing, it's 16
A drone?
My dad has one of those big fancy drones.
so that's going to be 90.95, so 90.95 inches. So we go ahead and take this, for the Mercury Mariner, we want to take this thing right here, divide it by 90.95. So 50 to 80 times 12. I'm going to divide it by ANS, second answer. So 676.7, oh, 696.7. Okay, so we subtract them, right? So if we subtract these two, what do you get? Yeah, so 770
What? What am I having?
minus ANS. We'll just minus ANS.
Second
Peyton,
answer.
you don't like me?
So about 74.3 revolutions, right?
No, I do.
74.3.
Oh, yeah.
That was so funny.
Revolutions difference, right?
I would not be offended at all that Peyton is hungry.
Dang.
Okay. So,
Oh, well,
we're having some like marital discussions back there somehow. I don't know what's going on. Okay,
Honestly, bro, I don't know.
now riding to learn, it is unwise and in some cases illegal to equip a vehicle with wheels of larger diameter than those for which it is designed. If a 2006 Ford Taurus were equipped with 28-inch tires, how would it affect the odometer, which measures mileage, and speedometer reading? what would it do? Now remember the Ford Taurus, we figured out was traveling at, how many, 60, was it 62 point something miles per hour?
Yeah, 62.
Yeah. And so if we go ahead and equip this with larger diameter tires, how would that affect the odometer reading?
The odometer, or I think and the speedometer, it would read lower.
Yeah, so odometer would read a little bit lower, right? In fact, we can calculate how much lower by just a ratio, couldn't we?
Right.
So it'd be like 26.16 over 28, right?
Oh, we are?
So if we do this,
28.
was it 28 point something? Yeah, so it'd be that. So it'd be, sure get this right here. 26.16 over 28.
Made it.
So we'd get over 6% lower, right? So quite a bit lower odometer reading it would show. Why would it be illegal to do that?
But when we,
Because it messes with the odometer.
yeah, the
It
odometer.
turns out in the air.
So yeah, so it would make the mileage seem lower than it really is on the car, right?
Also, it's dangerous with the speedometer, because like, it'll say you're going 50, but it might be going like 55.
Yeah, that's right. That's right. So you pretty much articulated pretty well what that is. So we'll just leave it there, and we'll come back tomorrow and start work on 45. And that puts us at level with the other class.